Everyone, welcome back. Today we will look into the easy level problem on Leetcode called remove one element to make the array strictly increasing. Before moving forward, I would like to mention that our focus is on improving the problem solving skills. So please pay attention to the explanation in this video so you can apply these techniques to other coding problems as well. Make it part of your thought process and keep practicing. Let's go into the problem now. The problem statement is given a zero indexed integer array nums, which we can also say input, return true if it can be made strictly increasing, or you can say ascending, after removing exactly one element, or false otherwise. If the array is already strictly increasing, return true. Strictly increasing, it means that there should not be any element matching with other also. It has to be in increasing order only. And we need to remove exactly one element to make that strictly increasing possible. So let's understand in more detail. What is strictly increasing? As I mentioned, that greater than the previous element till we complete the array parsing. For example, here if you see that input 1 is greater than input 0, input 2 is greater than input 1, 8 greater than 7, input 3, 9 is greater than input 2, 8, and this condition is satisfied till the end of the array. So this array is called as strictly increasing because from beginning the next element is always greater than the previous element, right? So let's try to understand this problem and solution further. We need to remove exactly one element to make the input array strictly increasing. So it will be depending on based on the input array. There will be different ways to make the array strictly increasing. For example, in this array, input array, if you see 1, 7, 8, 9, 5, if we remove the 5 from the end, the rest of the array becomes a strictly increasing. So based on this input array, we need to remove from it. And based on the next input, if we remove from the beginning, then the rest of the array becomes strictly increasing 7, 10, 12, 15. Sometimes we might need to remove from middle to make the array strictly increasing. For example, here 1, 7, 10, 8. If we remove the 10, then the rest of the array can become the strictly increasing like 1, 7, and 8. Some of the in cases where it is not possible to remove any element from end, beginning, or middle, we need to return false because we are not able to make that array strictly increasing even after removing one element. So in this example 1, 1, 1, if we remove any element, it will not become strictly increasing. Similar to the previous example, this is the one more example where if we remove any element, you can see that it is not becoming strictly increasing, right? So let's understand the base case here. Every coding question will have a base case. So during interview, you need to clarify with the interviewer what is the base case here so that for those base cases you can handle quickly. So where you directly need to send the output whether it is true or false based on that particular base case. Here in this problem, you need to always return true with the array of length 2. Why? Because if you remove any element, then array will have just one element. One element itself can be considered as increasing as there are no elements in array to compare with. You will not have any element to compare with. So that's why it is considered as increasing only. And the assumption of this problem is that you will have array of length 2 or greater than 2, right? So let's understand the solution by taking different cases. So let's say that we have this input array 1, 7, 12, 9, 11. We will use the two index method. One index, which is a left, we will start from beginning, and one index is a right which will keep at the end of the array. So we need to increment the left index till the left plus 1 is less than right. Means the reason why left plus 1 less than right is because we need to stop when we have one element left, because we need to only remove the one element. The problem statement says you need to remove one element to make the array strictly increasing. And you can shift the left index to next index only if the next index element, which is 7 in this case, is greater than the current element at left index. So for example, left is at 0 and left plus 1 is 1, and the element at left plus 1 is 7. 7 is greater than 1. So increment it, keep incrementing it till we encounter that 9 is not greater than 12. So why are we doing this? Because from beginning we are trying to reach till the point where the array is in a already increasing sequence. Similarly, we will start from the left. We will decrease the right index. Why decrease? Because you are starting from the end. And in a strictly increasing array, if you start from, you will see the elements in a decreasing order, right? So start decrementing the right uh, pointer or right index till you see that the element at input right, which is 11, is greater than the element at input right minus 1, which is 9. Because this way, what we are saying that we will keep decrementing the right, and from right index to the end of the array, it is incrementing. It is already in an increasing sequence, right? And we need to keep doing this until the difference between left and right is 1, because we need to remove only one element, right? Now here the index left and right are at the middle of the array, right? So just check which element can be removed. How can we decide? Either you can remove the left element, or you can remove the element at the left index or the element at the right index. How will you? Because till left, from beginning till left, you have already parsed it. It means it is strictly increasing. From end to right, you have already parsed it because it is strictly from right to end, it is strictly increasing. So element at left, either you remove the element at left, it can be removed if the element at left minus 1, 7, is less than the element at input right. Why? Because if we remove the 12 here, then the array will become 1, 7, and the next element of 12, 9, 11. So if suppose 7 is less than 9, then we can go ahead and remove the 12 and we can say yes, true. We can remove the 12 and make the entire array as increasing, or keep the array as increasing. The element at right can be removed if input at left, which is 12, is less than the input at right plus 1, because we are removing the right. So the next element of 12 will become 11. So we need to check that to keep the array strictly increasing, we need to check that 12 is less than the element at right plus 1, which is 11, which is false. So in this case, the second condition is false. But the first condition, that whether we can remove the left index element or not, it is true, because left minus 1 is 7 and 7 is less than 9. So we can remove the 12 so that the rest of the array becomes strictly increasing. If we are not able to remove left and right, left element at left, and we are also not able to remove the element at right index, it means that this array cannot become strictly increasing even if we remove the any one of the element at index left or at index right. Let's understand the one more case. So let's say we started the left at 0, right at 4, keep incrementing the left till we see that the previous number, the current number is less than the next number, left plus 1. Now we can't go beyond 16 because left plus 1, 3. Input at 3 is a 6. 6 is not greater than 16. So left, we completed the parsing. Similarly, we start decrementing the right. 6 is less than 23, so right decremented. 6 is not less than 16, so right is now at a 3. Now, difference between left and right is 1, which is good. Now, which element we can remove? If we remove the 16, then we need to check whether 7 is less than right element at right. It is not. So we can't remove the left. But can we remove the right? If we remove right, then we need to check whether element at left is less than the element at right plus 1, which is 23. It is true. It means that we can achieve the strictly increasing array by removing the 6. So we will return true in this case. Another case is where you can't move the left index stays at the beginning. In this case, it can't go ahead because 3 is not greater than 15. But right is continuing parsing and coming till the left. 9 is less than 12, 5 is less than 9, 3 is less than 5. Now the difference between left and right is 1. If the left index is at beginning, then we can remove that because right has already came till left because the difference is 1, right? So if we remove the index element at left index, which is 15, then the rest of the array is 3, 5, 9, 12 is a strictly increasing because right pointer already passed and came till 3 from end. So in this case, we will return true. Similarly, there will be a case where your left pointer will move because the next element is greater, but your right pointer is not moving because the 12 is not greater than 19. So it won't move. It is not decreasing. So in this case, if it has already passed from beginning till the adjacent to right, it means that the element at right can be removed. If the right index is at the end, we can remove that because left already came till right. It means that if we remove the right, the other part of the array is already increasing. That is why the left index was able to pass, which is 1, 7, 10, 19. So in this case also we will return true. Yes, it is possible. In some cases, it won't be possible to make the array strictly increasing. For example, here, if you see that we start incrementing the left till 10, after 10 we cannot increment because 4 is not greater than 10. Right, we decrement because 4 is less than 5. Here, if we remove the input left, either the difference between the left and right is 1, which is good. Either we can remove the left or we can remove the right. If we remove the element at left, which is 10, then the array will not be increasing. 1, 7, 4, 55. Right? If we remove the right, then also array will not be increasing because 1, 7, 10, 5. So in this case, both the conditions becomes false. So we will return the output false here. Now another case where here we are incrementing the left till 10 because we can't go beyond 10 because 4 is not greater than 10. Here we came right, we decremented till 12 because 17 is not less than 12. Here if you see there are more than one element between the left and right. The difference is more than one. Now we can't, the problem statement said we need to just remove one element. So but difference itself is greater than 1. So we will not be able to achieve the strictly increasing array by just removing the one element. So here also we will return the false. So now let's understand the solution. So we declared the left index, which is beginning of the array 0, right index, which is end of the array, num length -1. This is the base case where we just return the true. Keep incrementing the left until there is a difference between the left and right is greater than 1, and the next element to the left is greater than the left current element at the left. So left plus plus. Similarly, once that is done, keep decrementing the right because we are coming from the end. And check whether the difference between the right index and left index is 1, because we can only remove the one element based on the problem statement. If yes, then add. If we are if we reach till the if the right reach till the left and left is still at the beginning, so we can remove the beginning element to make the strictly increasing array. Or if the left came till right and right is at the end, then we can remove the element at end, then also return true. Or if there is a way to remove left element, or there is a way to remove the right element. So if any of this is true and the difference between right and left is 1, then return true. Let's submit it. Great. So we achieved the 100% runtime complexity. So what is the runtime complexity here? Uh, so runtime complexity is basically depends on the input size. So here, let's say if the input array size is n, how much we are passing. So if you see, in a worst cases, we will parse the whole array, which is n. In best cases, we will end up passing less because we are doing using a two index method. We are passing from left also, we are passing from right also. But in a worst case, we will pass the entire array. So the complexity is runtime complexity is O of n. N is the size of the input array. Hope you understood the solution and explanation. If you like the video, please subscribe and share. Thank you.